Connecting 125 volts, 20 amps duplex receptacles to a dimming panel is a violation of the National Electrical Code. Dimming panels are specifically designed to control the light output of lighting fixtures, typically incandescent or LED bulbs. Receptacles, on the other hand, are intended to supply power to a wide range of electrical devices, including appliances, power tools, and other equipment. These devices may not be compatible with the variable voltage and current characteristics of dimming controls. The National Electrical Code, or NEC, sets the standard for safe electrical installations. It addresses electrical components, systems, and equipment. The NEC aims to protect people and property from hazards that can arise from the use of electricity. The code is updated every 3 years to incorporate new technologies and safety practices. The NEC is adopted and enforced by many local jurisdictions. It is important to consult the specific requirements and regulations of the local area. Using receptacles with dimming panels introduces potential problems. Firstly, overheating can occur. Receptacles are not designed to withstand the fluctuating voltage and current levels that are inherent in dimming control circuits. This incompatibility can lead to excessive heat buildup within the receptacle itself, increasing the risk of fire. Secondly, damage to electrical devices is possible. The voltage fluctuations produced by dimming controls can negatively affect the performance and lifespan of electrical devices connected to the receptacles. Some devices may be particularly sensitive to voltage variations and could experience malfunctions or permanent damage. Thirdly, nuisance tripping of circuit breakers is a possibility. Dimming controls can cause unexpected surges or inconsistencies in current flow, which may trigger circuit breakers or fuses to trip unnecessarily. This can disrupt the electrical supply and inconvenience users. The National Electrical Code prohibits the connection of receptacles to dimming panels to mitigate these risks. Instead, receptacles should always be connected to dedicated circuits that are independent of any dimming controls. These dedicated circuits provide a stable and consistent voltage supply suitable for powering a variety of electrical devices without the risks associated with dimming circuits. By adhering to the National Electrical Code and separating receptacle circuits from dimming panel circuits, it is possible to create a safer and more reliable electrical system. This protects both electrical devices and the building occupants. The purpose of a dimming panel is to provide variable voltage to lighting fixtures. The dimmer varies the root mean square, or RMS, voltage supplied to the lights, which in turn changes their brightness. This is typically achieved by using electronic components like tracks or silicon-controlled rectifiers, which rapidly switch the voltage on and off, effectively chopping the alternating current, or AC, waveform. The RMS voltage determines the amount of power delivered to the light, and by adjusting the RMS voltage, the brightness is controlled. Receptacles are designed to provide a consistent voltage supply for general use. Connecting general-purpose receptacles to a dimming panel can lead to several issues due to the incompatibility between the fluctuating voltage supplied by the dimmer and the requirements of devices plugged into the receptacles. The fluctuating voltage from a dimmer can cause appliances and other devices to malfunction. Many devices are designed to operate within a narrow voltage range, and significant deviations from this range can lead to reduced performance, damage, or even complete failure. Fluorescent and LED lamps often include electronic drivers or ballasts that are sensitive to voltage fluctuations. These drivers are designed to convert the incoming AC voltage to a direct current, or DC voltage suitable for the lamp. When the input voltage is unstable, the driver may not be able to maintain a consistent DC output, resulting in flickering, reduced light output, or premature failure of the lamp. Electronic devices such as computers, televisions, and audio equipment typically contain sensitive electronic components that can be damaged by voltage fluctuations. These devices often include internal power supplies that regulate the voltage to protect the internal components. However, excessive voltage variations can overwhelm the power supply and cause damage to the internal circuitry. Motors found in appliances like refrigerators, washing machines, and power tools are designed to operate at a specific voltage and frequency. A fluctuating voltage can cause the motor to run erratically, overheat, or experience reduced torque. This can lead to premature wear and tear on the motor and potentially damage the appliance. Heating elements found in appliances like toasters, space heaters, and hair dryers are designed to generate heat based on the applied voltage. A fluctuating voltage can cause the heating element to overheat or produce inconsistent heat, leading to reduced performance or potential safety hazards. For example, Article 406.3F of the NEC specifically addresses the prohibition of using dimmers to control receptacles. This section aims to ensure that receptacles are supplied with a stable voltage suitable for the devices they are intended to power. The NEC provides specific requirements for the types of receptacles that can be used in different locations and applications. These requirements are designed to ensure safety and prevent electrical hazards. For instance, ground fault circuit interrupter, or GFCI, receptacles are required in damp or wet locations, such as bathrooms, kitchens, and outdoor areas to protect against electric shock. Arc fault circuit interrupter, or FSI, receptacles are required in many residential locations to protect against electrical fires caused by arc faults. Tamper-resistant receptacles are required in locations where children are present to prevent them from inserting objects into the receptacle slots. In addition to receptacles, the NEC also covers the requirements for electrical panels, which are used to distribute power throughout a building. Electrical panels must be properly sized to handle the expected load, and they must be installed in accordance with the NEC requirements. Circuit breakers or fuses are used to protect the circuits in an electrical panel from overcurrents. These devices are designed to trip and disconnect the circuit if the current exceeds a certain level. It is important to use the correct size circuit breaker or fuse for each circuit to ensure proper protection. The NEC also addresses the requirements for wiring methods, including the types of conductors and cables that can be used in different applications. The NEC specifies the ampacity or current carrying capacity of different conductors, which is the maximum amount of current that a conductor can safely carry without overheating. It is important to use conductors with the appropriate ampacity for each circuit to prevent overheating and potential fire hazards. Grounding is another important aspect of electrical safety that is covered by the NEC. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. Bonding is the process of connecting metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electric shock. The NEC also addresses the requirements for surge protection. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. SPD are typically installed at the service entrance of a building or at individual pieces of equipment. The NEC provides specific requirements for the installation and wiring of SPD. Electrical inspections are an important part of ensuring that electrical installations comply with the NEC. Electrical inspectors review electrical plans and inspect electrical installations to verify that they meet the requirements of the NEC. Electrical inspections help to identify and correct potential electrical hazards before they can cause problems. Continuing education is essential for electricians and other electrical professionals to stay up to date on the latest changes to the NEC. The NEC is updated every 3 years, and it is important to understand the new requirements to ensure safe and compliant electrical installations. There are many organizations that offer continuing education courses on the NEC. The use of extension cords and power strips should be carefully considered. While they can be convenient, they can also be a safety hazard if used improperly. Extension cords should be used only temporarily and should not be overloaded. Power strips should be surge protected and should not be daisy-chained together. It is important to follow the manufacturer's instructions when using extension cords and power strips. When working on electrical systems, it is important to use the proper personal protective equipment, or PPE. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. PPE helps to protect workers from electrical shock, burns, and other injuries. It is important to inspect PPE before each use to ensure that it is in good condition. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout involves disconnecting the equipment from its power source and placing a lock and tag on the disconnecting means to prevent it from being re-energized. It is important to follow lockout/tagout procedures whenever working on electrical equipment. Regular maintenance of electrical systems is essential to ensure their continued safe and reliable operation. Maintenance tasks include inspecting wiring, tightening connections, and testing circuit breakers. It is important to keep electrical equipment clean and free from dust and debris. Professional electricians should perform maintenance on electrical systems. The NEC contains requirements for emergency systems, such as emergency lighting and backup power systems. Emergency systems are designed to provide power and illumination in the event of a power outage. The NEC specifies the requirements for the installation, wiring, and testing of emergency systems. The NEC also addresses the requirements for hazardous locations, such as areas where flammable gases, vapors, or dusts are present. Hazardous locations require special electrical equipment and wiring methods to prevent explosions and fires. The NEC classifies hazardous locations based on the type and concentration of hazardous materials present. Article 517 of the NEC covers the requirements for healthcare facilities. Healthcare facilities have unique electrical requirements to ensure the safety of patients and staff. Article 517 addresses the requirements for essential electrical systems, isolated power systems, and patient care areas. Article 547 of the NEC covers the requirements for agricultural buildings. Agricultural buildings often have harsh environments that can be corrosive to electrical equipment. Article 547 addresses the requirements for wiring methods, grounding, and bonding in agricultural buildings. Article 550 of the NEC covers the requirements for mobile homes and recreational vehicles. Mobile homes and recreational vehicles have unique electrical systems that must comply with the NEC. Article 550 addresses the requirements for wiring methods, grounding, and bonding in mobile homes and recreational vehicles. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. Following the NEC is essential to ensure the safety of people and property. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes.